Hi, I'm Caleb McGrady, and this is my presentation on the airport scheduling project that I will be doing to complete ENGI 350 at Liberty University. For this project, I will be using IBM LPL Cplex and specifically the constraint programming feature of this program to schedule a standard day's incoming and outgoing flights at the Springfield-Branson Airport, along with the several constraints that I will create to make a feasible schedule. To schedule these incoming and outgoing flights at the airport, I will need several constraints. Some of these include the number of flights at the airport at any given point because of limited terminal space, overlapping constraints to allow for transfer flights from one destination to another, time constraints for planes being at the airport with minimum and maximum time links, as the plane has to be at the airport for a minimum time, but they can't just stay there all day, and then this program will schedule incoming and outgoing flights for the 10 gates at the airport and the airline companies who use the airport. Now I will show you my coding in IBM LPL Cplex and how I went to solve this problem. So first, I initialized that I was going to be using CP, which is constraint programming, and then I listed my problem description with the description I already gave, plus the different destinations where the flight will go, and specified more of the constraints. And then I went to my data input, and so this integer open is the length of time the airport is open in 15-minute intervals, and then the number is the maximum number of flights. Destination, there's 14 destinations that the airport will fly to, and then the number of gates is the number of gates that planes can load at. And then with this, I needed to create ranges for the destinations and number for my array. And then I also made a string array of cities, and I linked that to the destinations. And also a shift, which is the number of shifts at the airport, which will help in the scheduling process later. And so now I'll go over to the dat file. And you can see here's the value for the open, and then here's the value for gates. And then here's my shift array, which is 10-hour shifts. And then here is my flight list with the cities, so the different airlines with their cities that they will fly to. And then here is the list array of the flight 1, flight 2, flight 3, flight 4, flight 5, and then the layover period for each corresponding city. So this one would be the first row, second row. And how I created these layovers was a randomly generated matrix in Excel. So over in Excel, you can see how I created this randomly generated 14 by 5 matrix, and I just used the formula ran between and then the low integer and the high integer, and it'll just print out random numbers for the corresponding layover times, and then I would just transfer those into that matrix in LPL. And so next you can see I created a tuple, which is named flight, which is basically the entities in the array, and they correspond with the first number is the flight number, and the second number is the layover time. And then here is where I created the list of arrays over in the dat file. And as you can see, I used the tuple flight to create it and use the D in destinations and N in number. And then next I created my decision variable, which is an interval, which is the flight time that the flight is at the airport. So the first number would be when it arrives, and the second number would be when it leaves. And same, I used the destinations range and the number range, and I made it optional because not all flights have to have 5 numbers, but some of them will, and some could just have a few. And then I made it the size of this list array, and use the layover period to link them together. Next, I created my objective, which was to maximize the sum of destinations and number of flights while limiting the presence of the flight and destination and number array. And so to do this, I had several constraints. First, there could be no overlap for flights to the same destination, and there had to be a gap between the flight departure and the arrival of the next flight for that destination. And so to do this, I did for all the destination and number, range, I end before start, which is a constraint that will specify that this first value must end before this next one must start. And so flight DN must end before flight DN plus 1, which would be the next flight for that city, can arrive. And then this 3 over here means that there must be a time period of 3 between these two flights to allow a gap between their departure and arrival. This next constraint for flights cannot arrive after the airport closes. So for all the destination and numbers, the end of the flight for each destination number must be less than or equal to the open time, which was the hours of operation for the airport. And then the next constraint, the number of flights at the airport. So for all the n and the numbers, the sum of the destinations when they are present, so when they equal 1, it must be less than or equal to 10 because there's only 10 gates. So there couldn't be more flights than gates allowed. And then for all the destinations, the sum of the numbers when they are present must be greater than or equal to 1, which means there must be at least one flight for each destination in a day. And so then I created an execute statement, and so I will print out a dash line, and then I will print out the city name, city flight name, and then another dash line, and then it will print out the flight if it is greater than 0. So if it is chosen, it will print it out, and it will write in the time period where it starts and the time period where it ends. And so it will print out a nice formatted result. And so as you can see, I ran my program, and this is the solution it gave. So the maximum number of flights possible would be 50. And then for each city, you can see the flight number and when it arrives and departs. And each one has a variable number of flights that they will allow. And it'll do that for each city. And then with this result, it also printed out a nice Gantt chart to show the flight block and the randomness of the layovers, as you can see. Through this project, there were several lessons I learned. One was how to use the LPL scheduling constraints effectively, and specifically the presence of constraint, which I had not used before, and that was really helpful. And then also to schedule constraints for arrays instead of just individual entities. And then also how to map string values to values in the array for a nice formatted output. To conclude, I was able to create a feasible flight schedule based on the varying number of flights, limited number of gates, terminal, no overlapping for flights to the same destination, and time constraints for operating hours of the airport.